there! On the previous module, we have talked about homogeneous mixtures. And this time, we will be learning what a heterogeneous mixture is. Are you ready? Let's begin! Look at the sample mixtures here. Try to define what is a heterogeneous mixture. Look closely on each examples. On the first example, we have a mixture of water and ice. On the second example, we have a mixture of milk. And on the last example, we have a mixture of oil and water. Now, from these examples, what do you think is a heterogeneous mixture? Heterogeneous mixture is a non-uniform mixture. Its appearance is not the same. The substances present in the mixture can be identified easily. Let's study each example. What is the first example? What substances can we see in this one? That's right. There is water and there is also ice. As you can see, we were able to name the substances present easily. Why? That's because we can see them clearly in the mixture. Being able to identify or see clearly the substances present in a mixture is a characteristic of a heterogeneous mixture. The water and ice sample is a kind of heterogeneous mixture known as suspension. What is a suspension? A suspension is a mixture of a solid and a liquid substance where the solid residue settles at the bottom after left alone for some time. What happens to the ice cubes when you put them in the water? Besides the fact that the ice cubes will melt, they will also settle in the bottom. The same thing happens when you put soil in water. We have known that mixtures with substances that settle at the bottom are suspension, like the examples that we have here. How about those substances that do not settle at the bottom, but floats? Examples of these mixtures are milk and oil with water sample. So, what do you call these kinds of heterogeneous mixtures? Colloid. Colloid has substances that do not settle at the bottom, but floats even after left for some time. Most of the colloids look like homogeneous mixture, but are really not. Like the milk that we have here, let's prove that the milk sample is not a homogeneous mixture. Now, what makes milk a colloid and not a homogeneous mixture? Milk has particles that do not dissolve, unlike homogeneous mixtures. Milk particles just float. Let's try to compare a homogeneous mixture sample and a colloid. For the homogeneous sample, we have in here water with white sugar. And for the colloid sample, we have milk. We will be using a flashlight to demonstrate the differences between them. As you can see, the water with white sugar sample reflected the light, while in the milk sample, we can only see its shadow. Basically, the milk sample did not reflect the light. The particles in a colloid mixture scatter light, giving the mixture a Tyndall effect. That's the reason why we cannot see a reflected light like the one in the homogeneous mixture sample. Let's try to study a type of colloid that we often use every day. Can you guess what it is? Yes, it is oil and water mixture, our last example. In this sample, oil floats in water. Why? Because oil is less dense than water. Colloids, as what we have discussed earlier, has particles that float. And in this case, it's the oil. This kind of colloid is what we call as immersion. Immersion is a mixture of two immiscible substances. What are immiscible substances? Immiscible substances are substances that won't mix with each other, like the oil and water. as what we have seen earlier, it did not mix, right? So those are immiscible substances. But the question is, will oil and water not be mixed forever? Immiscible substances can be mixed, but with the use of an emulsifying agent or emulsifier. What is an emulsifying agent or emulsifier? It is a substance used to mix immiscible substances. Basically, we just put another substance to mix the immiscible substances, and that substance that we put is known as emulsifying agent or an emulsifier. Let's experiment. Put water in a glass, and then pour slowly the oil in the mixture. Did the oil and water mix together? Look at them. It's still reacting, right? Is it mixing? No, it's not mixing. They did not mix. Why? What happened to the oil? The oil just floats. Because it's less dense than water, that's why it floats. But what do you think will happen if we will add the detergent? The detergent is the emulsifying agent or the emulsifier. Can you still remember what is an emulsifier? Yes, that's right. That's the substance that we will put in the immiscible substances so that they can be mixed together. Let's try to mix them together and find out what will happen. Alright, as you can see, it's slowly mixing. Alright, we were able to mix oil and water together. Let's check if a light can pass through in this mixture. Let's have a flashlight test. As you can see, we can only see the shadow of this mixture. No light is reflected in the paper, just like on our previous demos or experiments. Therefore, this is still a colloid. Alright, we have just learned that a heterogeneous mixture has two types, suspension and colloid. We have also learned the difference of colloid and homogeneous mixtures, and that colloid has different kinds, but we just only focus to only one kind, and that is immersion. Immiscible substances can be mixed together with the use of an emulsifier or emulsifying agent. Oh, we have learned a lot today. We have talked a lot today, and I hope you have learned them all. I will see you again on module.